Hi everyone, this is Dr. Lesher again. This video is to introduce you to the metric units that we'll be using in chemistry class. In chemistry, we're often talking about things that are really small, and we're often talking about lots of those really small things. So we need to use convenient ways to quantify them. So question, how big is a carbon atom? What unit should we use to quantify that? We'll need a really small unit for measuring the size of an atom. We often use metric units. We also sometimes use SI units. In some cases, they're one and the same. In other cases, they're a little bit different. The metric system is based on units of 10, and that's why they're really useful for scientists. They're a lot easier to use than our feet and our ounces and things like that. And then the SI unit, the SI stands for Système International. It's a French word, French phrase. And this is just kind of the acceptable set of units for a subset of scientists. But really, in practice, in my experience, scientists use both SI units, metric units, Celsius, Kelvin. We see all of it. So you need to be aware of all of them. Then the next part is that we modify those units with prefixes. And so there's a list of prefixes here. There's also a list of the symbols that represent them and the value that they represent. So for example, kilo, this little k here, represents 1,000. And it's listed in both the decimal notation and the exponential notation. And so you've probably heard of a kilometer, a kilometer. That's 1,000 meters. If we look at a meter, this is a meter stick on the bottom of the video right now. If we zoom in on that meter stick, we see some gradations. So looking at these whole numbers, 1, 2, 3, 4, 5, 6, 7, you'd see these on a meter stick, and these are centimeters. So a centimeter is 100th of a meter. The whole meter stick would go from 0 to 100. And then you'll notice that the lines in between, say the 5 and the 6 here, there's 10 of those lines. So each of these lines is representing a millimeter. So the trickiest part here, the thing to work on, is how to apply these unit prefixes. So I kind of think of it as kind of building a new unit. So if I wanted to use a really small unit to quantify the diameter of an atom, I'd probably want to use one of those prefixes that represents a very small amount. And so two possibilities might be nano or pico. So nano being 10 to the negative 9th, or 1 billionth, and pico being 1 trillionth. So when we put that prefix before the m for meter, we get 1 nanometer, which is 10 to the negative 9th meter, or 1 picometer, which is 1 trillionth of a meter, 10 to the negative 12th. So the actual measurement of a carbon atom, its diameter is 3 times 10 to the minus 2nd meters. And if we want to avoid this, large exponential in the diameter term, we should use a smaller unit. We should use a nanometer or a picometer. So how would we express that? Well, if we want to use picometers, what we want to do is figure out how to express that 3 times 10 to the minus 10th in that smaller unit. So what I've done here is I kind of pull out that exponential term. So 10 to the minus 10th can also be expressed as 10 to the second times 10 to the minus 12th. This is the scientific notation work that we did in class on Wednesday. And if we kind of massage it in that way and pull out those two terms, we can sort of re-express this as 300, the product of 3 times 100, or 10 squared, times that 10 to the minus 12th of a meter. And then that 10 to the minus 12th, that's our pico. That's what pico means. So we can re-express this as 300 picometers. What about if we wanted to use nanometers? That would work too. Really, you can use any unit for any measurement, it's just that some are more convenient than others. So if we want to use the nanometer, we need to sort of pull out that 10 to the minus 10th and express it in terms of 10 to the minus 9th. So if we pull out a 10 to the minus 1st, you can see that if you multiply together 10 to the minus 1st and 10 to the minus 9th, you'll end up with 10 to the minus 10th. So like I did before, I'm going to take the product of 3 times 10 to the minus 1st, that gives us just 0.3, and then that 10 to the minus 9th of a meter, that's going to turn into our nanometer. And that arrow is a little bit off, it should be pointing right to that 10 to the minus 9th. That's what nano refers to. So I could express this measurement as 0.3 nanometers. Another application of units and just knowledge regarding units is that oftentimes we'll do calculations with units, and we'll see this a lot. And the thing to remember is that a unit is a lot like a number. It has to be sort of considered throughout the calculation. So if you're taking the area of something, length times width, both the length and the width might be measured in meters, and so the units on that area should then be meters times meters, or meters squared. Same with volume, that would end up being meters cubed. And then if you're doing a calculation where you're dividing two measurements, such as a density, where you do mass divided by volume, you've got units that have a fraction bar in them. So the mass, if it's measured in kilograms, divided by the volume, if it's measured in meters cubed, the units end up being kilograms over meters cubed. And just a few more SI units to point out to bring to your attention. We won't see some of these in chemistry, but SI units for temperature are Kelvin. We'll see that. And we'll also get into moles very shortly in this class, and I'll save that for another lecture. So I'd like you guys to try to work out what a better unit would be for expressing these measurements. And let's do one together. I'll just do it verbally. I don't have my pen today. But let's look at this one right here. 10 to the 6th, or a million volts. What's the prefix that represents a million? It would be mega, a capital M. So a million volts here could be expressed as 1 megavolt. And a few more on here that you can work on your own. Okay, thanks.